Hey everyone, thanks for tuning in. Let's have a look at another exam question. So a car manufacturer is to develop a new model to be produced from the 1st of January 2016 for 6 years until the 31st of December 2021. The development cost will be 19 million on the 1st of January 2014. It's going to cost 9 million on the 1st of July 2014 again, and then 5 million on the 1st of January 2015. 6,000 cars are going to be produced from 2016 onwards. All are going to be sold. The production cost will be $9,500 pounds during 2016. It's going to increase by 4% each year. First increase will start in 2017, and all the costs are going to be at the beginning of each calendar year. The sale price is going to be 12,600. It's going to increase by 4% each year. First increase will start in 2017, and all the revenue is going to be received at the end of the year. So what is the discounted payback period at an effective rate of interest of 9% per annum? Alright, so let's just get an idea over this. So this is time 0. This is where we're starting over here. So this is where 19 mil is coming out. We have 9 mil in the middle of the year. And we've also got 5 mil over here in 1 year's time. So over here is when the first cost is actually going to be, first variable cost is going to be occurring, £9,500, which is at the start of 2016. But then 2017 will be when the first amount of money comes in. So in fact, this bit over here is then going to increase by 4%. This 12,600 will increase at the end of 2017, start of 2018. So over here, this is going to be our last payment of 12,600 times some growth factor, however many years ahead that is. I haven't looked at that. So that's going to be where the last bit of money comes in. This is going to be where the last bit of money goes out over here. So let's find the discounted payback period. Alright, we're just going to make the cost equal the benefit. So let's say 19 plus, let's do 9 million. We've got to discount that back half a year, plus then 5 million discounted back 1 full year. And that's going to be equal to, we're selling 6,000 cars, and then we're going to be earning 12,600. But when we discount our 12,600 back, we're going to be going back 1, 2, 3, 4, 5 years over here, because that's when we first get it. Okay, so in this case n will be 5. But this 5 years over here, we still got to discount it back 3 years, 1, 2, 3, to get to the time where we are. So I'm going to discount that back 3 years, and then we can multiply by our annuity to find the present value at this point in time. So I'm going to call that 0.04 A due, and we don't know what n is. We're finding how many years it is until we can pay back all those costs. And then it's minus our £9,500, which we're going to discount back 2 years instead of 3 years, because we're finding the present value at this point over here. So we've only got to discount that back 2 years to get to there. And then we're going to be multiplying that by 0.04 A due n, and in fact this is the exact same thing, this bit here and that bit there. It's just at different points in time. Doesn't really make a difference. Alright, so now all we have to do is just jump onto Excel, and we know all the numbers except for n, so we can just literally solve for n. So let's get started on that. As you can see, I worked it out before, just to make sure that I still got it all right. So I'll get rid of that and we'll start it again. So let's just do some numbers over here, and let's just say this is the interest rate. This bit over here will be 1 divided by 1 plus the interest rate. And then this bit over here, sorry, in fact I should derive this formula for this bit because I don't think I've done it before, or maybe just briefly. But in fact, our 0.04 A due n is going to be equal to 1 minus v to the n divided by 1 minus v. But in this case, v is going to be equal to 1 plus the growth rate divided by 1 plus the interest rate. And the growth rate will be 0.04, and the interest rate is 0.09, as we know. So that makes a big difference, and we're going to figure that one out. And I can derive this formula for you at some point if you like, just a whole video on that. But that is 1.04 divided by 1.09. And here we go. So now let's find out what the costs are going to be equal to. So I'll just write it like this and say that we've got 19 million plus 9 million multiplied by the discount factor to the power of half, and we're still using our regular discount factor, plus 5 million. 5 million times our discount factor, and it's just 1 year. And there we go, but this is in millions, so you throw it 32.2 million. So in fact, I'm just going to find it in the dollar form, and sorry, I should times it by 1 million. And the reason for that is because I don't want to be using 6,000 as a decimal and be seeing how many points that goes back. I don't really care. Okay, so this bit's useful. And now we can start solving for n. So we'll take that and we'll divide that by 6,000, get rid of this bit, and then we're going to take this amount here and we're going to divide it by 12,600 times v to the 3 minus 9,500 times v to the 2 and take out this annuity as a common factor. So that's going to be equal to this amount divided by 12,600 times v to the power of 3 minus 9,500 times v to the power of 2. And there we go, we have some number over here, and this bit is equal to our growth annuity. And our growth annuity is this bit over here. So we've got to multiply our left-hand side by 1 minus v. And that's the capital V that I worked out. So this multiplied by 1 minus this new discount factor that we have when things are growing geometrically at 0.04. So we're looking at that. And then this bit over here is equal to 1 minus v to the n, this top part of the equation. So I could just find 1 minus that. This bit here equals v to the n. If I find the natural log of that, it's equal to the natural log of this bit over here. And now all I have to do is, because I found the natural log to both sides, that's going to be n log v is equal to this bit over here. So if I divide that by the natural log of v, I should then find what n is equal to. And in actual fact, this is going to be n. This is n that we've found. But this is n at the start of 2016. Okay? So if I say here, n is equal to, I can't remember what I found, it was 3.262. That's how many years from here is when we're going to get our money back. 1, 2, 3 and a bit. So we're looking about there. In actual fact, we get paid here. So we've got to discount this back 2 more years. So I can just add on, call this n plus 2, will be equal to 5.262 years. Okay, so that's saying from when we're starting here, it's going to take 5.25 years till we get paid. But in actual fact, we're not getting paid in the quarter of a year, we're getting paid at the end of the year. So unfortunately, we've got to increase this bit and say we're only getting our money in 6 years' time. Okay, 6 years' time is when we're going to be able to pay back all of our costs based on the assumptions that we've made over here. So that's the answer. And now let's just look in this bit over here. Without doing any further calculations, explain whether the discounted payback period will be greater than, equal to, or less than the period calculated in part 1 if the effective rate of interest was substantially less than 9% per annum. Well, in fact, even though it said not to do any calculations, let's just have a look and see what it looks like, because this is a time when we can muck around. So let's just pretend that the interest rate is 1%, not 9%, because it said to make it lower. So there we go. Let's see what happened to n. It actually decreased. So first of all, that's our answer. We're decreasing it. But why are we decreasing it? Well, let's have a look at what happened. Our cost amount, this bit has hardly changed. In fact, it's only gone up by like 0.7 or so, which isn't very much. Whereas our income would have been going up a lot more, so we'd be able to cover the cost quite a bit sooner. So since the bulk of our offsets, of our outsets, are done at the start of the period, then we've actually got, we can really cover that. But if we had this 19 million being paid in 10 years' time, then there would be no way we'd be able to be covering that so soon. So in fact, we've got a +2 to this and then round it up a bit. But as you can see, that's really how it's worked. So it's going to be decreasing, and we can also look at that and say, then if we say that the interest rate, and that's going to be against the present value or the net present value, we could say, as the interest rate decreases, then that's going to increase. So we're going to have more money quite a bit sooner. Okay, and that's why our discounted payback period will be decreased. So thanks a lot for watching, and if you've got any questions, then post it, and if you want me to derive anything, let me know.